Okay, so I want to talk about superheat just a little bit and some facts about superheat that you may or may not know. Okay, we know what superheat is. Superheat is a method that we use to charge when we have a fixed orifice. So we know a fixed orifice is one of these guys here, and we know that inside the holder we're going to have a piston, and that's the fixed part. There's a fixed hole in that piston, and we put them together and we put it in our machine. That's our metering device, and it's fixed. It doesn't change. It can't adjust to the load, right? So when we have a fixed orifice versus a thermostatic expansion valve, then we have to charge by superheat. If we had an expansion valve, we'd be talking about subcooling, but because of the fixed orifice, it's superheat. So I want to bring up some facts about superheat that make you know it's a little more complicated, requires a few more steps, and it's not one number fits all. So first of all, I've got a chart on the table here that's going to show us how we would obtain a superheat number, a target number. It's based on an indoor wet bulb and an outdoor condenser temperature. All right, so to get wet bulb, we're going to have to use a device that can measure wet bulb temperatures, typically a psychrometer like this. We have to get wet bulb. Can't skip that part. So we're going to go inside. We're going to measure wet bulb. In this room right now, the wet bulb temperature is 64 degrees. The air temperature is not 64. The wet bulb temperature is 64 degrees. The outside temperature where the condenser is 75. So this chart is going to tell us what superheat we would need at those temperatures. And I want to show you that. So let's go to our indoor wet bulb. I told you it was 64. That's right here. And then we're going to move across until we get to the outdoor 75, and right here we're looking at our target superheat at this particular temperature would be 18 degrees. Okay, now if it warms up outside, that's going to change. If it warms up or cools down in here, that's going to change. We have to go back to this chart over and over again. So as the day changes, the superheat requirement is going to change. Now it doesn't change a lot when we're dealing with subcooling. So keep that in mind when you're making your decision. Do I use a thermostatic expansion valve or a fixed orifice? Because you're going to have to go through all of this with the fixed orifice versus a much simpler subcooling method. Now to take this a step farther, I'm going to bring up another chart. We're going to use that chart. This is just going to be a little more facts about it, just to show you how far it can range. So this is the same house. We're talking about the same house. Basically, it's that morning, right? So you show up at that house in the morning, and it's 75 degrees inside and 75 degrees outside. Very common for a morning service call. Okay, but based on the humidity indoors, which would change our indoor wet bulb reading, the superheat could either be 20, 10, or 6. Okay, same inside temperature, same outside temperature, but because of the humidity changing our wet bulb, you might be looking for a 6 degree superheat or a 20. Now go back that afternoon to that same house again when it's 90 degrees outside, right? The sun came out, warmed the place up, 75 degrees inside. Now you're going to charge that house, that same house you visited this morning, you went back this afternoon. Now look at it. Depending on the humidities, whether the indoor humidity is 69, 62, 54, or somewhere in between, you could be looking at a 3 degree superheat or a 10. So my point being is in this one day, we could have went from 3 degrees to 20 degrees of superheat need simply based on temperature changes. So I want to drill home the fact that with a fixed orifice, we don't just say, hey, I need a 10 degree superheat. It doesn't work that way. We have to consult the charts. The manufacturers publish them on all their equipment. If you're going to use a fixed orifice, you must use a chart, you must use wet bulb, and you must charge it accordingly for that moment in time. So take all the data, charge it correctly, consider a TXV, it will make your life easier.